Oh man, I sure do love collecting random sets of numbers, but they're all scattered around my house, and they're all not in order. Man, I sure do wish there was a way to magically sort all these numbers in order of lowest to highest value, while being grouped up by similar value numbers in an algorithmic way. Hey, it seems like you should learn about counting sorts. How the hell did you get in my house? Hey, it's me again, Void Boy, real name John Vincent. And have you ever wanted to sort random numbers by counting them? No? Why not? It's fun. Who doesn't like sorting a bunch of data in an orderly manner? You? Well, that's why you, yes you, need to learn about counting sort, so that you can make your own C program that does it for you. Now before we begin, what is counting sort anyway? Counting sort is a non-comparison based sorting algorithm that sorts elements by counting the numbers of occurrences of each distinct value in the input array. So unlike other sorting algorithms like bubble sort, selection sort, or quick sort, counting sort doesn't need to compare elements directly, skipping the tedious process that these other sorting algorithms do. It uses the actual values of the element to determine their correct positions in the sorted output. Now, how does it work? Well, let me show you. Cool, right? What just happened there, you may ask? And to that, you might want to get comfortable, because there's gonna be a lot to cover. As the name implies, the basic idea of counting sort is to count how many times each value appears in the array, and then use the information to place the values in their correct sorted order. First, find the maximum value in the input array. This is important to determine the range of values we're going to be needing in our count array. Once you have the max value, create a count array with the size equal to the range of input values. Now, how does this work exactly? Well, let's say that you have 9 as your maximum value. Then that would mean you'll need an array with at least 9 indexes, including index 0. Oh, and make sure it initializes all elements to 0. After that, count the occurrences of each value in the input array by incrementing the corresponding index in the count array. Next, modify the count array so that each index stores the cumulative count. Basically, imagine you have this unsorted array. You need to count how many times the same number occurs and keep track of them, which should look like this. Once we have counted, we'll have to add them all together. Index 0 will add to index 1, and index 1 will add to index 2, and index 2 will add to index 3, so on and so forth, until you have this. If your count array now looks something like this, then you're in the right track. This is what defines a counting sort. This part is usually tricky though, since it'll usually have the values way above the numbers you expect. But trust me, the magic of counting sort lies in those values. Once you've done all of that, build the output array by placing elements in their correct positions based on their count array. This is where the magic begins. We'll start by looking at our original array. Let's look at our first element, which is 3. We then check the index 3 in our count array, which gives us the value of 3. Again. We then use the values as an index for our output array, which tells us that the first element 3 should go to index 3 in the output array. Afterwards, we decrement our count array by 1 so that the next element 3 won't go to the same occupied index. You then repeat the process until you have the fully sorted array. And finally, copy the output array back to the original array, finishing the whole process. Complicated, right? But if you execute this in code, it'll look straightforward. I might even say it's more efficient than bubble sort. But what would it look like in code, you may ask? Well, let's find out. It's coding time. Yo! Welcome back to coding time. Okay, let's get straight to it then. I'm back here again in CodeCham using my account in EBSU, my ex-EBSU college account. Let's get to it. So, before we get started, we need to initialize our array. Initialize array, and then we'll put on a random number. So, let's say 4 to let's say 8, 3, 3, and 1. Yeah. So that's gonna be our array. It's filled with our elements there, and let's make int n. This is for our size. So size of array, and then we divide that by size of array 0. There we go. So what's this for? This is how we get the size of our array right here. Why not just say like just like 1, 2, 3, 4, 5, 6, 7? Like why not like I just say that n is equals to 7, not all of this? Well, that's because you can with this you can add another element. Let's say 9, and that will automatically turn this into the exact number of elements inside this array. So yeah, with that out of the way, let's go first with the first step on how we're gonna get the counting sort to work. That's by finding the maximum value. So let's go max equals our array starts with 0, because our array always starts with 0, because to find the max we have to go through all of this one by one, and to do that we need a for loop. So for int no, that's an for int I equals 1, and then an I is less than n, and I increments. There we go. Why are we starting with 1 and not 0? Because we've already set that our max is equals to array 0, so we don't really have to go through that again. Then let's say if our current our current index is greater than our max, then we'll say that our max will now equals to the array. Okay, so now that we got that, this is how we're gonna get our max value. And once we have our max value, we're gonna have to make our count array. So we're gonna go ahead and say int count. Let's just say count to max. So as we've established before, the max here is supposed to be how we can tell how many what do you call this? How many elements there are in the count array, because we're gonna be counting all of the numbers here that is present. But we'll also have to plus 1 this. I almost forgot, because you need like you're including index 0 with this, so we need to plus 1 it so we could get the accurate size of all of it. Okay, then we're gonna make our other array, int output. This is gonna be our output array, and the size of this will be n. Remember this? Yeah, this is why we did all of this. Ooh, almost got, make sure that the spelling is correct. I almost had that to an error. And then we initialize the count array. We need to fill this up with zeros. Remember in our steps that I discussed before. To do that, we're gonna use another for loop. For int I equals 0, I should be less than or equals to max, 0, and then I increments. Where's my? And we're just gonna say that every every current index should equal to 0. You could also use this with calc, but I prefer this because it's gonna be more readable in the video than the calc one. Okay, and once we have all of that, our array, our cut array should look something like this. Hold on, let me just display what it would look like. Printf count. Oh, wait, actually, we need to do another for loop for that. I'll just show you. I'll just show you how. This is how it would look like now. Print this nope. This. Let's make sure space and then count I. Oop. Oh my god, we don't have Wi-Fi. Oh no. There we go. As you can see, our count array is simply just a bunch of zeros, but if we count them down, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, why is there 9 here? Because we, as we established before, got the max value, and our max value in our array right now is currently 9. Yeah, that's how it works. So let's just get rid of that and continue forward. Then we'll have to get to, hold on. Then I forgot. We make this for loop int I equals to 0. Wait a minute. I think I got this wrong. Wait, no, I'm right. Except make this 1 actually. I equals to max. We're gonna go I increment. Okay, so in this for loop, we're gonna be counting the occurrences of the numbers. So as I previously before, this is what defines a counting sort. So this is where we're gonna be counting all of the repeating numbers like 2 and 3 here. And to do that, we have to do this count, and inside that count is array, and inside that array is I, and then we go ahead and increment that by 1. Now, what does this do? Remember before that our array in the count array right now is 0, 0, 0, 0. So this basically means that in our array, our current array, I is 1, right? Okay, so it's gonna go ahead. Wait, is it 1? Oh, my bad. God damn it. This should be 0. So our current array should be 0. And it's gonna be finding what the value of array index 0 right now, and in here it should be 4. And since the value is 4 here, this count array will look for index 4 because it's 4 here. And once it does, it'll go ahead and find its index 4 in its array and then add it by 1. Let me just show you that by printf and then d space and then our current what do you call this, count, and I. Okay, as you can see here, when it like found like 4 here, like, you know, it has a 4, and so it's gonna go look for index 4 in its count array and then add by 1. And we can see here it's 0, 1, 2, 3, 4, so it added by 1 over here, and then it'll go increment to the next value, which is gonna be 1. So it's gonna look at 2. Because it's array 1, and array index 1 is 2. it's gonna go to index 2 and add it there, and it's gonna go ahead and do that repeatedly until you have this. Wait, something's wrong here. Okay, so apparently I was being dumb. I placed the count, like to read to print that count here, when I realized that I'm still counting it. It's still not the final. It's like going, displaying the count. I mean the array, the count array, along with it being still counted. So, that's why it was wrong and printed like wrong stuff. So everything here is actually correct. It's just that my demonstration was not in a correct way. So I'll have to do this to show you that it's actually working right now. So yeah, right there, everything's okay. So if we run our code here, hold on. Okay, so here we go. So 0, 1, 2, 2. Yeah, so this is the correct count right now. So in here, our count array is now changed from all being zeros to having like counting. So now, so 4 here, we're gonna go find array. It's gonna go inside 4, and then it's going to the index 4 and add that by 1. So as we can see here, 0, 1, 2, 3, 4, that's 1. And then it's gonna go for the other 2, so 0, 1, 2, and then there's 2 2s, so now there's 2. Then they're gonna go 3, there's 2 3s, 1 1s, and 1 8 and 1 9. So yeah, this is correct now. So I was just being dumb by putting this here. Not advisable. Do not do that like I did. Okay, so let's continue where we left off. Kind of got lost in the sauce there. Now that we have our count array, we've already counted occurrences. We're gonna make another for loop. So a thing about counting sort is that there's gonna be a whole lot of like for loops here. So int I equals to let me just see 0. I is equals to max, and then I plus plus. I no, that's not I plus plus. So where did where am I? Okay, so what am I doing right now? So oh wait a minute. No, it's actually I1. Read that wrong. And this should be, yeah, that's max. We're gonna be making the accumulative one. So here we go. We're gonna go ahead and add all of this together. So to do that, we're gonna have to say count I plus equals count I plus minus 1. So why are we doing it like this? So basically, we're gonna go ahead and take array 1 because we're starting at 1, and we're gonna go add that and assign, so plus equals to the count to 1 count index 1 minus 1, which should be 0. So basically adding the previous index to the current index, and that's what we need to do to get what we need. So I can actually do this to show you demonstrations. Just need to change no, oh wait, actually I'm not doing the same mistake again. This is different. Okay, so take this out and actually do this. Copy that. This should work. Whoops. Just gonna wait till it shows up. And it's not showing up anymore. Okay, it showed up. So it was just my Wi-Fi being dumb. Oh my god. Okay, so back here, as you can see, we've already done the accumulation, this one. So from our previous, like just counting, so we're just, now it's adding up. So 0 plus 1 should, 0 to 1 should be still 1, but 1 to 2 will turn it to 3, 3 to 2 will turn it to 5, 5 to 1, 6, and then keeps on going 6, then 7 and 8. So we're going to be needing this new set of array to get the proper location of our to sort our array. So just gonna go ahead and do that. I should probably like take this out. Yeah, you know what? This is what I'm gonna do instead, so that we can see what we're doing here. So we're just gonna say this is a count array. Do that and say that this is gonna be our like position array, something like that. Position array. I'm also gonna do this just to make sure it's gonna go to new line when there's a new code here. After all of that, we're gonna go and finally build our output array. So we're gonna go ahead and make another for loop. So that's gonna be we've already made so much, but that's count sort for you, baby. So for loop int I equals n minus 1, and then in that n minus 1 is I should be greater than equals to 0, and I decrement this time because we're going backwards. This is how we're gonna be going backwards through the array, and in the code should be, the code block should be output. Our output array, inside our output array is our count array. Inside that count is the array itself. So it's an array inside an array inside another array. Pretty wacky, right? Actually, before that, we have to actually put -1 in this one. -1, and that should equals to array 1. I mean, no, not 1. I. Then we're gonna go ahead and say count, and then array, and I, then decrement that. So let me just explain how this all works. So basically, we're going backwards through the array, right? We're starting at n minus 1. So basically, we're starting at 0, 1, 2, 3, 4, 5, 6, 7. So we're starting at 7. 7 minus 1, so that's 6. Because if you look at it in an array, there's only 0 to 6 on its indexes. So 6, and then it's gonna make sure that I is greater or equals to 0, and then we're gonna keep on decrementing the I after the code block is done. So basically going backwards through backwards to our array. So yeah, I'm gonna go start at 9, then 1, 3, 3, 8, 2, 2, 4. And we're doing that because we're doing all this. So in our output array, it's gonna look for its index should be our count array, which has the value of index value of our array. So it's very, very complicated. So let's start at the very inside of this array fest here. So array 1, I, and our I right now starts at 6. So array index 6 minus 1. So our array index 6, which should be like 9, and then that array that 9 will be minus by 1, so our count array index should actually be 8. And if we see through our what do you call this, our count array, that 6, no, not 6, where was it, 9, that's 9, 8, I mean 8, you know what, it's much better, more better to show the code. What am I doing? Ooh, what's this? Ooh, don't forget the semicolon. Always not forget about the semicolon. So, as you can see here, we're going to be starting off 9, remember? 9 minus 1, so 8. So count array index 8. So we're going to go ahead to go count array. This is still our count array, by the way. We just renamed it to position array so that we can know. 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's in index 7. So our index for our output should be in index 7. And in index 7, we're gonna be putting our array, our current array, which is also in 7, should be in index 7. So it's gonna stay right there because this is still index 7. Because 0, 1, 2, 3, 4, 5, 6, 7. Yeah, it's gonna stay at index 7. But then, once we decrement that and go to index 6, which is 1, index 6 over here, this will be 1 now, and 1 minus 1, that'll be 0. So in the count array, that should be 0. So 0 right here. So since this is 0, our output array will go ahead and like look as it's gonna put on output index 0. So our array 1 should go to input 0, index 0. So this 1 should be over here right now. So basically, yeah, it's rearranging our stuff. Let's go ahead and print that actually so that we can know. Let's say that this will be, actually I have a better idea for this. We're just gonna go ahead and go to the final step and actually copy our output array back to our index array. So int I equals 0, I should be less than n, then I plus plus. We're gonna go ahead and our array should equals to our output array. There we go. To our output array, and then we're gonna have to print if this is gonna be our sorted array, and inside will be for loop, another for loop, and I equals 0, I n, and then I add, and then just gonna go here, and we're gonna go ahead and print if, and it's gonna be d space and then our array, our current sorted array now. So yeah, that should do it. That should do it. 0. If our code is right, this should be, oh no, what happened here? Okay, so I found a problem. It was this. So so I did a little dummy thing again. I put -1 here. Oh, whoops. I placed it here instead of being outside. So basically my count array was not like, how do I explain this properly? The array this array value should not be minus by 1. This instead, this, like the count array, should be the one being minus by 1 to accommodate with the index 0. So with that with that corrected now, we should be having the sorted array. So let's go ahead and check. Executing. Yep, right here. So if we can see here, 4228331 and 9. It is now 1223348 9. So it's finally sorted, guys. A lot of difficulties right there. Count sort can be confusing at times with it having so many for loops and like this here. My God. Actually, wait, hold on. Let me just test this out. Okay, so I'm back again. I basically added more onto the sorted array here to see if I can actually like sort everything in order. And yeah, as you can see, even as how many you put in your array, it should still output a sorted array. See, 1, 2, 4, 5, 6, 7, 8, 9, 9, 9. So yeah, that's basically it for a counting sort. Counting sort is an efficient sorting algorithm, when the input falls within limited range, that is. While it's not a general purpose sorting method, it excels in specific scenarios where speed and stability are required. Understanding counting sort helps illustrate how algorithms can be optimized by taking advantage of data characteristics rather than relying solely on comparisons. Hey, thanks for sorting all my numbers and all, but can you leave my house now? Yes, of course. By the way, what's the date today anyway? I still need to submit this video at the 21st. Dude, it is the 21st. Yeah, shit.